Everybody, Mr. Buckley here with some examples from Algebra sections 10.3 and 10.4, solving systems using substitution, and then we're going to use some addition here also. So we're going to solve the following system of equations using substitution. So a system is a pair of equations where we want to find the point at which both of these equations are satisfied at that given point. And we're going to solve this using substitution. So we know that both of these functions, or both of these equations, are equal to y. So 5x minus 25 is equal to y, as is negative 8x and 20 plus 27. So what I'm going to do is take 5x minus 25 and plug it in for y in the second equation. When I do that, I get this equation. 5x plus negative 25 is equal to negative 8x plus 27. I can write that because I know that both of these things are equal to y, so they must be equal to each other. Once we have this, we can solve using algebra. And I'm going to do two things at one time. I'm going to separate the left side from the right side, and then I'm going to do two things at one time. I am going to add 8x's to both sides to get rid of this minus 8x. And then I'm going to add 25 to both sides to get rid of this negative 25. And why I do this, even though that might be a little confusing that we're doing several things at one time, once these things start to cancel out, it will hopefully become a little bit clearer. So what happens is the 25's cancel out because negative 25 plus 25 is 0. The 8x's cancel out because negative 8x plus 8x is 0. And then we're left with 13x on the left-hand side because 5x plus 8x is 13x. And 52 on the right-hand side because 27 plus 25 is 52. Dividing both sides by 13, I get x equals 4 because 13 times 4 is equal to 52. So I know that the value of x in this function, in this system of equations, is 4. And if I plug in 4 into either one of these x's, I will get our value for y. And if I plug in 4 into the top equation, 5 times 4 is 20. 20 minus 25 is negative 5. So the solution to this system is 4, negative 5. Next system here, we have y equals 2x, which is in slope-intercept form, and then we have 7x plus 5y is equal to 34, which is standard form. So we're going to use a little different method of substitution here because we don't have two equations that are in slope-intercept form. So we're going to take this value of 2x and plug it in for y. We're going to substitute 2x for y in the second equation. So I'm going to rewrite the second equation, and what just appeared on the screen there is the second equation. The only difference is I don't have a y there. I have 2x because 2x is the same thing as y. So now I have 7x from the 7x right here. These two are the same thing. The plus 5 from right here. This plus 5 and this plus 5 are the same thing. The y is gone because it was replaced with 2x, and it was replaced with 2x because 2x is the same thing as y. So this y becomes this 2x, and this equals 34 from the equals 34. Combining like terms, doing some multiplication here, doing a little bit of simplifying, what I get is 7x plus 10x. The 10x comes from 5 times 2x. 5 times 2x is 10x. This equals 34. Combining like terms, I get 17x equals 34 because 7x plus 10x is 17x. Dividing both sides by 17, I get x is equal to 2. So I know that the value of x in our solution has got to be 2. To find the value of y, I'm going to go back to our original two equations and plug in 2 for x. The top one would probably be a little bit easier, even though it doesn't matter which equation I use. And if I plug in 2 in for x in the top equation, I get 4. Because 2, this 2 right here, times x, which is 2, would be equal to 4. So 2, 4 is the solution to this system. And we can verify that solution. Solve using substitution again. Now we have a value of x, which is equal to y minus 2, and then we have 2x plus 3y equals 1. Substituting in y minus 2 in for x, because I know that y minus 2 is the same thing as x, I get this equation here. This is the bottom equation. The only difference is I replaced x with y minus 2. This 2 is from right here. The x is gone. The x has become y plus negative 2 or y minus 2 because those two are the same thing because y minus 2 is the same as x. Plus 3y, which is equal to 1. The plus 3y equals to 1 here is the same as the plus 3y equals 1 here. What I'm going to do to simplify this is do some distribution. I'm going to do 2 times y, which is 2y, 2 times negative 2, which is negative 4, and then plus 3y equals 1. So I distributed to get rid of those parentheses. Now I can combine like terms to get 5y plus negative 4. The 5y comes from 2y plus 3y, plus negative 4 is from right here, equals 1 is from right here. Basic algebra at this point, I want to solve for y, so I'm going to add 4 to both sides and get 5y equals 5 by adding 4 to both sides to get rid of this negative 4. The opposite of negative 4 is plus 4. Divide both sides by 5 and I get y equals 1. So our value for y in our solution is 1. We need a value for x. So if I plug in 1 in for y into the top equation, which would probably be easier, so I know that y has to be equal to 1. So 1 minus 2 is equal to x. 1 minus 2 is negative 1. So the solution to this system is negative 1 for x and 1 for y. Now we're going to solve using addition, a little bit different process here. So solving using addition is we're going to take two functions, or two equations, that are not solved for either of the variables. Notice we don't have a x equals something or a y equals something, and we are going to combine the two. Sounds weird, but we can combine the two. So what I'm going to do is take these x's and combine them. I'm going to take these y's and combine them, and then I'm going to take these constant terms and combine them. When I combine these two x's, this is a positive x and a positive x. That gives us 2x. So we're going to have 2x here, and the 2x comes from x plus x. And then we have 0y. Well, where does 0y come from? 0y comes from this positive y minus y. And y minus y is 0 y's, so they're gone. And then this is 10, because 8 plus 2 is 10. So now really what we have here is 2x equals 10, because the y's are gone, because we added these two equations together. Sounds weird, but we can do it. So we have 2x equals 10, and if 2x equals 10, therefore x has to be 5. And now that we know that x is 5, we can go back to one of our original two equations and plug in 5 for x. I'll plug it into the top one. 5 plus what equals 8? 5 plus 3 equals 8. So x has to, or y has to be 3. And we can even verify that with the other equation. Is 5 minus 3 equal to 2? Yes, it is. So the solution to this system using addition is 5, 3. And one more. We have 2x plus y equals 4 and negative 2x plus 3y equals 8. We're going to solve using addition. Notice that all of our terms here are lined up, x and y, and then our constant terms. So we're going to use addition. So we're going to combine these terms, we're going to combine our y terms, and we're going to combine our constant terms. So notice 2x minus 2x is 0. Y plus 3y is 4y. And 4 plus 8 is 12. So here our x's go away, because 2x plus negative 2x cancel out and become 0. So therefore we have 4y equals 12. And if 4y equals 12, y has to be 3. So y is equal to 3. So then we plug in 3 in for y. So 2x plus 3 equals 4. And if we solve this using algebra, we will find that x will have to be 1/2. 2 times 1/2 plus 3 is equal to 4, so therefore our value for x has to be 1/2. So the solution to this system is x equals 1/2 and y equals 3.